What was the first moment in history? It depends what we mean by history. If we mean every event, then it begins with the universe. But if we mean a story we can trace, history needs a record. It needs a mark that stays. So the first history we can read is written in light. There's a faint glow across the sky, left when the young universe cooled and light could travel freely. It's the earliest page we can see. Before that, the universe was too hot and crowded to let a clear trace pass, so we can't look further with light. On Earth, the records get personal. Rocks and ice hold ages. That's nature remembering. But human history asks for meaning we share on purpose. Maybe it starts with a hand on a cave wall, or a shaped stone kept because it mattered. And then speech carries moments across minds, and later, writing carries them across centuries. The first clay tablets with numbers and names in the first cities let a day stick to a date. So, what was the first moment in history? It sits wherever memory begins, in ancient light, in stone, and, for us, in the first mark we meant to keep. Did time start with the universe? It's odd to ask if time started, because to start anything you need a before. Yet that's the puzzle. In Einstein's picture, space and time are stitched together, and the Big Bang isn't an explosion in space. It's the moment space and time, as far as our equations can see, come into being. So asking what was before is like asking what's north of the North Pole. It's a real question, but the map runs out. But maps can be extended. The very first instant is hidden under quantum fuzz, where gravity and the tiny world mix. There might have been a bounce, or a phase before ours, or time might be something that emerges from change, the way heat emerges from many moving atoms. If that's right, there could be a deeper time that doesn't look like the time we keep with clocks. What we can say is this: the arrow we feel, from past to future, traces back to a beginning in a very smooth, low-clutter state. As the universe spreads and settles, disorder grows, and that's why memories point one way. So did time start with the universe? The time of our history likely did, at that hot, dense beginning. Whether there's a wider time beyond it is still open, and worth the wait to learn. Was there a before the Big Bang? We ask that because our lives run on clocks, and clocks point to a before and an after. But the Big Bang isn't an explosion in space, it's the start of space and time expanding, so the usual idea of before may not fit. In our best picture, time is part of the universe, not outside it. So asking what came before the first moment can be like asking what's north of the North Pole. The word works, but the place doesn't exist. Still, there might be more. Some ideas say the first tick wasn't the first ever, because a universe could have been shrinking, then bounced and grew again. Others suggest a strange state with no time, where time appears only when the universe spreads out and cools, and there are models where new regions keep forming, each with its own clock, so before depends on which clock you mean. We feel the pull of the question because we live inside time and we expect a cause behind every start. But the start might be the cause, or time might be larger than our piece of it. So, was there a before? Maybe not in the way we mean it, and maybe in a way we don't yet have words for. That's where our map currently ends. Could time ever begin again? It's a strange question, because a beginning already uses time, so asking for another start sounds like pulling yourself up by your own laces. But time is part of the universe, not a stage outside it. If the universe can make something new, then a new clock can start with it. Our time seems to start at the Big Bang. That's not a firework in space. It's the moment space itself switched on and stretched. Before that, the idea of before may not make sense, because there's no clock to point at. But there are ideas where the universe bounces, or where a black hole gives birth to a new patch of space with its own seconds. In those stories, time doesn't rewind. It begins again locally with its own first tick. Why would it have a direction at all? Because the world began in a tidy state, and mess tends to grow. That growing mess gives us the arrow of time. So a fresh, tidy beginning would set a new arrow. We know smaller versions of this. A birth resets a family. A loss does it too. The same sunlight, but a new calendar in the heart. So could time begin again? If reality can make new space with new conditions, then yes, not our clock restarting, but another one starting from zero. Why does time move forward instead of backward? An egg falls and it shatters, and we never see the shards leap back into a shell. So why does time pick a side? The basic rules for atoms almost work both ways, like a film that could be run forward or backward and still make sense. But there's one rule that breaks the tie. Left alone, things spread out. Heat flows into cold, smells fill a room, order turns to mess. We call that spread entropy, and it counts how many ways the parts can be arranged. So time's arrow isn't pushed by the laws each second. It's set by where the universe started. For reasons we're still chasing, the early universe was very ordered. Fewer possible arrangements, fewer ways to be. From that special beginning, there was only one easy direction to go, toward more spread, more possible arrangements. That's why coffee cools, why stars burn their fuel, why we age, and it tells us why memory points one way. A record is made when entropy rises. A footprint presses into sand. Bits flip in a computer. Molecules settle in a scar. The future doesn't have those records yet, so we can't recall it. So time moves forward because the universe began in a rare state, and everything since has been the gradual loosening of that first tight knot. If nothing changes, does time still exist? It sounds simple, but it hides a trick. Time is the word we use for the order and duration of change. A clock is just a thing that changes in a steady way, and we compare other changes to it. So if nothing changed anywhere, no heartbeats, no atoms shifting, no stars moving, what would a clock even be? We could draw numbers on a line, but every mark would feel the same, because nothing would tell one moment from the next. In that frozen world, time would be like a rule with no game to play. The label is there, but the differences that make it real are gone. And that shows something honest. We don't detect time by peeking at a hidden substance. We notice before and after, cause and effect, memory and expectation. But our universe won't sit still. Even a rock is busy inside, and even empty space shows tiny flickers. Heat slides, light crosses distance, particles decay, and the cosmos expands. Change gives us a way to count, and counting gives us time. So if truly nothing changed, time would lose its meaning for us. It would be indistinguishable from not being there at all. And yet we're here, in a world that keeps moving, and that's why time feels real. Did light create time when it first moved? It's tempting to picture a first spark and time starting like a clock, but time didn't wait for light. Space and time arrived with the universe, so there wasn't a before to sit in. Light didn't turn time on. It moves inside time, and it shapes how we measure it. There is a rule baked into the universe, a speed limit. Light is what travels at that limit, so it marks the edge of cause and effect. If you could ride a flash of light, no time would pass between being made in a star and landing in an eye. For us, years go by. That contrast shows time depends on motion and on the path we take. Very early on, the universe was hot and thick, and light scattered in place. As it cooled, light could finally cross space. We still see that faint afterglow. So light didn't begin time, it revealed it, leaving marks we can read. And because we're human, Our time is tied to light, days and seasons, cameras and fiber lines. Atomic clocks count the steady beat of light from an atom. We live by those beats. So did light create time? No. It gives time a face, and it sets the pace that binds events into a story we can see. How old is time itself? It sounds like a trick, because when we ask how old time is, we use time to ask it. Still, we can say this. The time we live inside, the time tied to space and motion and change, is about 13.8 billion years old. It begins with the hot, dense start of our universe, when space opened and clocks could start ticking at all. Before that, the question may not make sense, because before needs time. It's like asking what's north of the North Pole. There may be ideas where the universe bounces, or where time stretches on in some larger way, but for everything we can measure here, the story starts at that beginning. And there's another layer. We feel time moving one way, from past to future, because disorder tends to grow. Eggs break and don't unbreak. Heat spreads. That's the arrow of time. It gives us memory, and it lets causes come before effects, and it anchors our lives to a direction. So, how old is time? For us, at least 13.8 billion years, because that's the age of the universe that carries our days. It could be that time is larger than that, or that time itself emerges from something deeper. But the part we inhabit began when there was something to count, and we've been counting ever since. Could there be a place where time never started? We ask it like there's a map, and somewhere off the edge the clocks don't work. But place is a space word, and time isn't a spot you can stand on. Time is the order of change. It's what we mean by before and after. So the real question is whether there can be a bit of reality where before never makes sense. Run the story of our universe backwards, and everything gets hotter and denser. We hit a boundary in the story, not a wall in space, but a limit to how far earlier goes. Some ideas say that's a true beginning. Others say the start is more like the South Pole. There's no more south, but there's no cliff either. The word just stops being useful. There's another thought. Time could be something that appears when things can change. If nothing can change, there's no ticking. So a realm where time never started might be a realm with no change to count. And then place fades too, because place is also measured by change. People live by firsts. First words, first loves, first days at work. It's how we feel the world. But it may be that our firsts are local. They belong to our patch of reality. Beyond that, the deepest layer might be timeless, and universes like ours switch the clocks on. Maybe that absence of a first moment is the reason moments can exist at all. Is time part of the universe or something outside it? We notice time because things change. A clock is just something that changes at a steady rate. So time, for us, is the order of change, and we count it with ticks. That already puts time inside the world. We've learned that space and time are joined, and gravity can warp them. In a valley, time slows a little, and on a mountain it speeds up. Planes and satellites have to correct for this, or their maps drift. Time isn't a backdrop. It's part of the machinery. What about before the Big Bang? That question sounds simple, but it hides a trap, because before needs time to exist. If time begins with the hot early universe, then asking what came earlier is like stepping past the edge of a map. Before loses its job there. Could there be a larger reality where our universe forms and fades with its own time running? Maybe. If so, our time would be a local feature, like weather inside a bigger climate, but we don't yet know. We feel time's arrow because disorder tends to grow. Broken cups stay broken, and memories pile up behind us, not ahead. That gives the future its open shape. So the answer is simple. Time, as we live it, is part of the universe, and it holds our days like a story held by its order. When did humans first notice time passing? It didn't start with clocks. It starts the moment a mind can hold a before and an after and feel the space between them. So it begins with change. Light fades, a shadow stretches, a belly grows empty, and a memory says it wasn't like this a moment ago. That's time arriving. Humans didn't invent that feeling, but we leaned into it because we could remember and we could plan. A child learns to wait, and waiting is time in the body. Our ancestors watched the sun slide and the moon swell and shrink, and they tied their lives to those steady swings. We see traces, old bones with rows of cuts that match the moon's cycle, made tens of thousands of years ago. A line of pits in Scotland, about 10,000 years old, set so the months don't drift and the midwinter sun resets the count. Later, stones catch the sunrise on the shortest day, so a year becomes a thing you can point at. But the first noticing is earlier than any monument. It's in a hunter reading tracks and knowing they're fresh, so the animal can't be far. It's in food stored because cold is coming. It's in grief, which is a before and an after held together. So the answer is ancient. Time begins for us when someone waits and watches change and knows it means something. Why does childhood feel slower than adulthood? It's odd that childhood seems to stretch and adult years slip by in neat weeks. But the clock on the wall doesn't change, so something in us does. Time in the mind is built from change and attention. When everything is new, the brain marks it, and it saves more detail. First school day, first snow, the first bike ride, signals everywhere. Those days fill with memory, so they play back slower. Later, life has more routine, and the brain predicts well, so it saves less. A week that repeats can fold into a single line. Scale matters too. A year at 6 is a huge slice of life. It's 1/6 of everything you can remember. At 30, a year is a thin slice, so each one feels smaller. Novelty brings a burst that sharpens attention, so moments stand out. Routine turns that down. When attention is split, we skim. Skim days don't leave many markers, so they feel short later. So childhood feels slower because it's dense with firsts and because each year looms large. The clock keeps steady, but our record of it expands or contracts. Some days fill a page and some barely a line. Why do boring days feel long and good days feel short? It's odd that the same clock sits on the wall, and yet some days stretch and others vanish. The difference isn't in time, it's in attention and memory. When nothing much is happening, the mind has little to hold, so it turns toward time itself. We start checking the minutes, and each check makes the gap feel bigger. The seconds get loud because there's nothing else to occupy them. But when a day is good, attention is busy. We're absorbed, so we stop measuring. The inner clock doesn't get checked, and the gaps close up. Hours slide by because the mind is filled with doing, not counting. There's a second trick, and it runs in the other direction. Looking back, a boring day leaves few markers. There aren't many distinct moments to recall, so it shrinks in memory. A good day writes lots of new pages. Small changes, new places, fresh faces. Each one is a marker the brain saves, so the day feels longer in hindsight, even if it flew while it happened. So time felt now comes from attention, and time remembered comes from how many changes we stored. Boring days feel long as we live them, and short when we look back. Good days feel short in the moment and long in memory. The clock stays steady, but our minds don't. Why do we always want more time? Because our lives are bigger than the hours we get. The brain keeps drawing futures, and it can draw dozens at once, but the day only has room for one. So desire grows wider than the clock. We think the task will take a moment, and it takes the afternoon because we picture the path without the bumps, and we remember the best parts of past days. So we plan a day made only of highlights, and real days never run that smooth. There's also how time feels. When we're absorbed, minutes slip, and we want more because it's bright. When we're bored, days smear, and we want more because we want another chance to make them clear. And there's the edge we all know. Our lives have an end, and that fact turns every hour into something scarce. Scarce things feel precious, and precious things are never enough. So a birthday carries a little ache, and the last light of a holiday feels short. Maybe we don't only want more time, maybe we want more say in it. We want space to choose the next moment, not just meet it. And in that wish is a simple truth. Time is the shape of our hopes, so it always feels one step too small. Can time heal everything, or just help us forget? We say time heals, but what actually changes is us. The event doesn't move. We move around it. Right after a shock, the body is loud with stress, and the mind keeps firing the same signal, so it feels like nothing else can get in. With days and weeks, the chemicals ease, and the brain starts to rewire. It isn't magic, it's practice and plasticity. We remember, and the memory opens, and the brain writes a new line next to the old one. Forgetting is when the details fade, because they don't get used. Healing is different. Healing keeps the facts, but shifts the weight. The meaning stays, and the sting softens, because new experiences attach to it and spread the load. That's why a song that once hurt can one day hold both pain and warmth. The signal is still there, but it no longer fills the whole channel. Not everything heals by waiting. A broken bone knits only if it's set. Some injuries need treatment, or truth, or repair. Left alone, they can harden into a shape that keeps hurting. Time can scar as easily as it can mend. So time isn't a doctor. It's the room things happen in. We don't simply forget. We change. And with enough change, the past can find a place to live that doesn't rule the day. Why does waiting feel so heavy? Because waiting is a kind of work, even when we sit still. The mind sets a goal and keeps it lit, like a small lamp that never goes out, and it costs energy to keep it on. Our bodies get ready to move, and then we tell them not to. So the engine turns, and the brakes hold, and that strain shows up as weight. We also run a clock in our heads. When we expect something, we mark a time. If it doesn't arrive, the error grows, and we feel that gap. Minutes spread because attention has nowhere else to go. We stare at the delay, so the delay fills the room. There's chemistry in it too. A signal in the brain tracks reward and timing. When a hoped-for thing is late, the signal dips and the world loses a little colour, and that makes time drag. Uncertainty adds another layer, because the mind starts rehearsing futures. It tries to prepare for each one, and that packing and repacking feels like carrying bags you can't put down. So waiting gathers muscle tension, spare energy, and imagined outcomes, and stacks them on the same moment. It's not emptiness at all. It's fullness without motion, which is why a door that stays closed can feel heavier than the one we finally push open. Is memory a way of holding on to time? Time moves in one direction, and everything changes. So how does a mind stay itself while the world keeps shifting? It keeps a record, not a film on a reel, but small changes in a living network that say, this happened, not that. Neurons fire together, and their links grow a little stronger, and that tiny shift is a mark. It's not the past itself, it's a description the brain can read and play back. And when a song opens a doorway to a summer long gone, it feels like travel, but it's reconstruction. The brain builds the scene from clues it's stored, and it fills the gaps. And that's why memories can be vivid and also wrong. Yet they do something vital. They stitch moments into a line. So a person isn't just a series of flashes, but a continuing story. Because memory isn't only about yesterday, it's mainly for tomorrow. The brain compresses experience into rules and expectations, so it can guess what comes next and act in time. Even writing, photos, and rituals are memory pushed outside the skull, so groups can share a longer thread. So is memory a way of holding on to time? It doesn't hold time still, but it lets us carry its imprint and walk forward with it. Why does time move differently in dreams? It's strange how a dream can hold a whole afternoon, and we wake and minutes have gone. Sometimes a chase lasts forever, and sometimes a city appears between two blinks. So what's going on? Time isn't a fixed beat in the mind. We build it from change. When we're awake, the world feeds us a stream, light shifting, footsteps, voices, the rhythm of our movement. And our sense of duration locks onto those signals. In a dream, that stream is cut off, and the brain runs its theatre. So it measures time by the story it's telling, and by how strongly it feels. Big moments get stretched because emotion turns up the gain. Empty parts get skipped because the brain edits as it goes. Our memory of a dream is stitched from highlights, with scene changes that jump like film cuts. When we recall it, we read those edits as long or short, and the length bends. There's a clue from labs. Dreamers count to 10 and signal with eye flicks, and it takes about as long as when awake. So inside the scene, actions often run near real time. It's the writing and the remembering that warp. So time moves differently in dreams because our inner clock becomes a storyteller, and stories don't keep minutes. They keep meaning. Can love make time stop for a moment? Sometimes the room seems to fall away and one face fills the frame. Time doesn't actually stop. The seconds don't jam. We're not bending space-time. We're changing attention and memory. But our sense of time isn't the clock. It's a story the brain builds from change. We measure time by how much is happening and where attention points. With love, the brain shifts chemistry, sharpens focus, and tags meaning, so the spotlight narrows and holds. Because the world outside that spotlight fades, the brain counts fewer changes, and the moment can go still. There's another trick. In strong moments, the brain writes more detail into memory. Later, that memory comes back wide and slow, as if it's stretched. Love often makes it pause, because we stop checking the edges and stay with the one thing we can't look away from. The clocks keep ticking, and the planet keeps turning. But two people can take the same second and live more inside it, and their hearts and breaths can even fall into step. So no, love doesn't stop time. It changes how time is made in us, and for a breath it is held. Do we feel time, or do we just imagine it? Stand in a queue and a minute stretches. Share a joke and the same minute flashes. So what are we actually feeling? Clocks agree about the minute, so there's something real outside our heads. Inside, the brain keeps time by counting change, heartbeats, tiny bursts of nerve activity, breaths. Under fear, the body fires faster, so more little events are recorded, and the moment feels dense, like extra frames. Under boredom, fewer events, so the story thins. Beyond us, time, ties change together. Planets spin, atoms tremble, and there's an arrow because heat spreads and order gives way. A dropped cup shatters, but the pieces don't leap back. So time isn't just imagined. It's woven into how the world works. but the feeling of moving through it is built. The brain holds a small present, a kind of short window, gluing what just happened to what's still arriving. Memory pulls the past behind us. Expectation tugs the future toward us. So do we feel time? We feel change, and we call the shape of that change time. And do we imagine it? We imagine the pace, because our counter speeds up and slows down. The universe sets the order. The mind sets the rhythm. That's how a minute can be both endless and gone. Who first decided how to measure time? It wasn't one person. It started with the sky, and then it became a chain of human choices. Day came from the turning earth, and month from the moon, and year from the march of seasons. But counting them took a decision. Early farmers watched shadows creep because work needed a rhythm. In Egypt, priests split daylight and darkness into hours, 12 and 12, by the rising of certain stars. That gave us 24. Another choice set the shape of the small parts. In Babylon, numbers were counted in 60s, so minutes and seconds fell out as 60 of these and 60 of those. Water clocks and sundials tried to hold that shape, even as summer days stretched and winter ones shrank. Then the machines took over. Gears made hours equal everywhere on a dial. Monks kept them, cities lived by them, and bells stitched days together. Railways forced a harder step. Town clocks had to agree, so time zones were drawn like lines on a map. The last step is the smallest. A second is now fixed by the steady beat of atoms, so a clock can sit in the dark and keep the world in step. So who decided? The sky set the scale, and we kept tightening it, one careful choice at a time. Why do we divide time into hours and minutes? We didn't always live by hours and minutes. A day arrives because the earth turns once, but the slices are ours. Early people watched shadows creep and stars appear, and they needed a way to share moments, not just notice them. So the day was split. Egyptian watchers gave daylight 12 parts, and night 12 more, because 12 matched the stars they used as markers. In Mesopotamia, counters liked 60, because 60 breaks cleanly into halves, thirds, quarters, and more. When circles were mapped, and much later, when clock faces turned, 60 fit the wheel. So an hour took 60 small steps, and each step could split again. Minutes and seconds are those smaller steps. They arrived as work, and travel demanded finer agreement. Ships needed the sky timed for navigation, prayers needed order, and later, factories and trains needed sameness from town to town. Equal hours replaced the old stretchy ones, and the grid spread across the world. But the reason stays human. We divide time so we can meet, build, and trust. An hour is a promise, and a minute is room to keep it. The planet keeps turning whether we watch or not, and we lay a measured thread over that motion, so a single day can hold many lives at once. Did clocks change how humans think? They didn't just tell us what hour it is, they changed what an hour is. Before clocks, time arrived with light and meals and chores, and it stretched or bunched with the day. Then we built machines that chopped the day into equal beats, and those beats slipped into our heads. An hour stopped being a feeling and became a measurement. With that, we could meet at midday, even if the sky looked different, and whole towns could move together like parts of a single device. Trains needed it, so maps gained lines of time, and distant cities began to share a now. This changed our thinking. We learned to budget minutes like coins and to plan by the clock. We started to treat attention and work as things that could be scheduled and counted. And when we could measure seconds, patterns in nature became visible that we'd missed. So guesses hardened into laws, because you can't test a cause without knowing when it happens. It also shifted the sense of self. There's the body's pace, And there's the schedule's beat, and much of modern life is fitting one into the other. So did clocks change how we think? They taught us to see time as a grid laid over experience. And once you see the grid, you think along its lines. Is being on time a modern idea? It depends what we mean by on time. If it means hitting a number on a clock, then yes, that's quite new. For most of history, people moved with events, not minutes, because the day was measured by light, shadow, and bells. Work began when frost lifted, boats left at the tide, markets opened when the square filled. A promise was around dawn, after the bell, before dark. Town clocks arrived, but every place still kept its own noon. It didn't matter if the next valley was a few minutes off, because the world moved slowly enough. Then rails and telegraph lines tied places together. Trains needed exact times, so we drew time zones and set clocks in step. Factories paid by the hour, schools rang bells, and punctuality became a rule as much as a courtesy. But the older rhythm never vanished. Fishers still meet the tide. Prayer follows the sun. Families plan around hunger, and our bodies keep time by light more than digits. So being on time is ancient in spirit and modern in precision. We live between the sky's clock and the one in our pocket. Would life feel different without calendars? We know it already on the first week of a holiday. Days stretch, meals drift, and the sun becomes the only signal. The world still turns, but the grid we pin to it is gone. A calendar is a quiet machine we share. It lets millions agree on when. So, work begins, trains meet, and birthdays land in a story we share. Without it, time would still move in lights and shadows, in warm months and cold months. We'd look up and read the sky. We'd plan by the next rain or the first frost. But the far future would shrink. Next Tuesday, next March, next decade, those are calendar inventions. They let us slide our hopes along a line and mark a promise. Memory would change too. Right now we file life by numbers. We say 2008 or the 12th of May. Without dates, we'd chain memories to events. Before the big move, after the child was born, age would soften into a story, not a number, and something else would change. A calendar is a social gear that bites with the motion of the Earth. It meshes our small plans with a planet's orbit. Without that gear, life might feel closer and warmer, but thinner at the edges where strangers meet. We'd still have time. We just lose the shared map that makes a future together. Why does the world move faster every year? It isn't the planet that's speeding up, it's our sense of time. And that shifts as we grow. A year doesn't change length, but its size changes compared to a life. When you're 5, a year is a fifth of everything you've seen. At 40, it's 1/40th. So each year feels thinner, like a smaller slice of the same circle. There's something else. The brain writes more detail when things are new, and it compresses what it can predict. Childhood is full of first times, so days get stored with rich markings. Adult life repeats, and the brain saves effort by guessing the next moment, then filing the day under the usual. When you look back, you step across fewer markers, so the stretch behind you feels short. And there's the world we've built. News, messages, updates arrive all day, and they split attention into tiny pieces. In the moment that can feel fast, because you're always catching up. But later, it feels thin, because not much was etched into memory. So the clocks haven't changed, but our bookkeeping has. Time seems to race when prediction wins and novelty fades. And it slows again, just a little, when we meet something that breaks the routine and asks the mind to notice. Do we control time, or does it control us? We grow older even when we do nothing, So it's easy to feel that time is the boss. The earth turns, seasons change, cells copy and wear out, and we're carried along. And there's a deep reason for that. Heat spreads out, order loosens, cups shatter, but don't unshatter. So there's a steady direction. That's the arrow of time, and we can't reverse it. But time isn't just a rule outside us, it's also a signal inside our heads. A boring minute stretches, and a joyful hour vanishes, because the brain measures time with change and surprise. Newness lays down more memory, so a day packed with firsts feels thick, and routine feels thin. So we can't stop the clock, but we can change how full it feels. And there's a stranger bit. Clocks don't all agree. High on a mountain, they tick a touch faster than at sea level, and astronauts come home a tiny fraction younger, because motion and gravity bend the rate. That shows time isn't a single drum. It's a fabric that can be tugged, but only a little by us. So do we control time? Not its direction, and not much of its pace. But we do steer our moments, and they add up to the only life we get. Why do we rush when time never runs out? The clock will keep ticking whether we hurry or not, and yet our body leans forward. We rush because our lives aren't endless, even if time is. A star can burn for billions of years, but a human gets a handful of decades, and every hour we spend on one thing closes the door on something else. Our brain treats those doors like alarms. When a chance is brief, it boosts our pulse and releases chemicals that sharpen focus. Deadlines and daylight don't wait. Clocks let us move together, and once we can measure minutes, we start to trade them. But time itself won't stop, so what are we racing? We're racing the shelf life of moments, and the limit of a life. Even in the cosmos, windows open and close. The early universe could make the first atoms, and that era ended. On Earth, seasons turn, and some chances last a week. So rushing is a way to match the timing of a world that changes. It's a signal that something matters now, and there's a choice inside it. Because if we can see that we're not trying to beat time, we can ask which doors we want to catch, and which we can let swing shut. We rush, not because time runs out, but because our moments do. Can progress exist without deadlines? Deadlines are lines we draw in time. They turn a vague aim into a date and a push. So can there be progress without them? Progress is change with a direction. It's not just motion. It's moving closer to something that matters. Nature does this without calendars. A child learns to speak with no date on the wall. A forest rebuilds after a fire. Stars form in clouds of gas because gravity keeps pulling. There's no countdown, but there is a force and a path. And people can do that too. Curiosity pulls. Practice lays down a track. Feedback tells us if the last step helped. So the work can grow because the reason is strong and the signals are clear. But in groups, attention phrase. We start many things, and urgent noise wins. A deadline gathers us, and it sets a shared moment. It isn't magic, but it aligns hands and eyes. It can also bend the measure. We hit the date and miss the point. We polish the easy parts and leave the hard heart of the work. So yes, progress can exist without deadlines. It needs a clear aim, steady rhythm, and honest feedback, plus time that isn't stolen. When we must move together, dates help, the clock helps, but the compass matters more. Will technology ever make time meaningless? We've built machines that pull far places close, and it's tempting to try the same with time. There are two kinds here, the time a clock measures and the time we feel in a life. Technology is good at the second one. Waiting shrinks. A message crosses an ocean in a blink, and a film from a century ago plays on a phone. But the first kind is stubborn. Change needs a before and an after, and that ordering is time. Even the fastest ship only slows its ticking. Relativity lets you stretch your hours by moving fast, but they're still your hours. And the universe keeps an arrow because heat spreads and disorder grows. We can push a local patch back by spending energy, but the bill goes somewhere. What if we live for 200 years, or we copy a mind into code, meaning still rides on sequence? A memory is a path through moments, not a pile of data. Pause the process and the experience stops. Resume it, and time returns with it. So no, technology won't make time meaningless. It may make waiting rare and lifetimes long, and it may teach us new ways to weave our days. But meaning needs change, and change needs time. That's the bargain we live inside. How does the Earth keep time? Every clock we build is a copy of a motion we didn't invent. The planet turns and the sky appears to wheel around us, so a day is one spin of Earth. The sun comes back to the same place, and that's our 24 hours. The planet also falls in an ellipse around the sun, so a year is one lap, and the tilt of Earth leans light back and forth and gives us seasons. It sounds simple, but the motions don't fit together cleanly. A year isn't an exact number of days, so we carry an extra quarter day each year, and we fold it into a leap day now and then. And Earth doesn't spin like a perfect machine. The moon pulls at the oceans and rocks, like a brake, so the spin slows by a tiny beat over centuries. So our clocks sometimes pause for a leap second to stay in step with the planet. Because we want steadiness, we define the second by the tick of atoms, which rarely drift, and then we nudge that atomic time to match the sky. Even gravity and speed tug time a little. So clocks high on a mountain tick a touch faster than at sea level. So Earth keeps time by turning and orbiting, and we keep time by listening and correcting. Do trees feel the passing of seasons? The year turns, and trees turn with it. But do they feel it? They don't have nerves or emotions, so not in our way. But they sense it, and they act on it. Leaves carry tiny switches that flip with light, and roots listen to temperature. As days shorten, those switches change shape and send messages. Temperature adds its vote. Together they say, slow the engines, shut the green factories, move sugar to the roots, build a kind of antifreeze, cells thicken, water is pulled back, ice has less to bite. Then leaves are released, not dropped in panic, but unplugged on purpose. In spring, longer light flips the system the other way. Sap rises, buds unlock, and the crown becomes time made visible. Even if light and warmth stay odd for a week, the tree has an inner beat, trained by years of sky, that keeps the plan steady. Wood grows fast in spring and early summer, then slows, then stops. That pulse lays down a ring each year, pale, then dark, like a line of memory. We write dates on pages. Trees write seasons into their bodies. Do they feel the passing of seasons? They measure them, they remember them in wood, and they live by them. And that sounds close to feeling, if feeling means being shaped by time. How old is the oldest rock on Earth? It sounds like a simple question, and then it turns. Earth formed about 4.54 billion years ago, but the surface was hot, and early rocks were melted and made again. So the oldest things we've found are tiny hard crystals called zircons in Western Australia. They're mineral grains, not whole rocks, and they were born about 4.4 billion years ago. They're specks that kept their clock running while the world changed. If we mean a complete rock, one piece with its story still joined, the record sits just over 4.0 billion years. The Acastic gneiss in Canada holds that mark at around 4.02 billion years. There's a claim in Quebec near 4.28 billion. It may be right, but it's debated because those rocks were cooked, and their clocks are hard to read. How do we read them at all? We watch atoms change inside, as one kind turns into another at a steady rate, and that ratio works like a built-in timer. Simple in idea, hard in practice. And this lands in a human place. A lifetime is a flicker beside those numbers, yet a hand can lift a piece of that time. The oldest rock we know is a little over 4 billion years old, and it lets us hold the Earth remembering itself. Does the planet remember everything that's happened? Not like a mind does, but the ground is full of traces. Walk a cliff and you're reading time stacked as stone, with seas that came and went pressed into layers. Trees keep the seasons as rings, and ice holds bubbles of ancient air like tiny time capsules. And when lava cools, little grains of iron lock in the direction of Earth's magnetic field, so the ocean floor becomes a barcode of reversals. So there is memory, but it's written as signals, not stories. But the planet forgets too. Rain smooths mountains, and rivers grind them down, and the crust sinks back into the deep, where heat and pressure erase the writing. Most of the ocean floor is young because it's recycled. So there's no perfect archive. There's a living one, always edited. Even so, big changes leave marks that last. Great extinctions show up as sudden shifts in fossils and chemistry. The rise of oxygen shows as bands of rusted rock. And our time is laying down its own unmistakable layer, with plastics in mud, and a spike of radioactive dust from old tests, and a sharp bend in the carbon threaded through shells and snow. So does the planet remember everything? No, but it remembers what matters to its shape and its climate and its life, and it remembers long enough to show us how we fit into its story. How many times has life started over? It depends what we mean by starting over. If we mean the first spark, the move from chemistry to a living thing, it looks like it happened once. Every cell we've found uses the same kind of code, the same letters, the same tiny machines. So all of us trace back to one ancient line, not many separate tries. But if we mean the world clearing the board and building again, that's happened more than once. There was a time when oxygen flooded the seas and air, and it was poison to most life. And yet it opened a door to new ways to breathe. There were deep freezes when ice reached the oceans near the equator, and only pockets of life held on. There were great die-offs, 5 big ones, when most species vanished, and the survivors spread out and re-stitched the living world. Even our own cells carry a restart inside them. The little power stations in our cells were once free-living bacteria, and that partnership changed what complex life could do, and bodies made of many cells evolved not just once, but in different groups, as if the idea kept returning when conditions allowed. So how many times has life started over? Once for the beginning, and again for the shape of the world we live in, with the thread never quite cut. Is evolution just nature's clock? It's tempting to picture evolution as a clock because it stretches over ages and seems steady. But a clock counts, and evolution doesn't count. It changes. It happens when instructions in living things are copied and slightly changed. And some changes help in a place and time, and others don't. Those that help tend to leave more copies, so the helpful changes spread. Clocks tick evenly. Evolution doesn't. It speeds up when the world shifts, and it slows when life fits well, and sometimes it leaps after disasters clear space. And there's no set destination. It builds eyes many times, and it shrinks eyes in caves, because only fit with the surroundings matters. So time is part of it, but time is the stage, not the gear. Being human feels like the top of a ladder, but there is no ladder. We're one branch among many. Our brains solved different problems, and that made language and cities. But bacteria solve theirs better in other ways. and they outnumber us by far. Evolution isn't nature's clock. It's the slow feedback of life with its world, where chance makes differences and survival edits them, and the edit that fits stays. That's why life looks designed yet isn't planned. It's been tuned by time, not told by it. Will mountains still stand when time forgets us? They look like forever, but they're not. They rise because the ground itself is moving, and plates push and crumple and lift rock into the air. The Himalaya climbs a little each year, and the Andes do too, because deep inside the earth there's heat that keeps the crust drifting. But wind and rain and ice tear them down at the same time, grain by grain, and rivers carry their weight to the sea. So a mountain is a balance, a tug of war, not a statue. Give it a few million years and peaks shift. Ridges soften, valleys widen, and new ranges grow elsewhere as old ones fade. Give it a few 100 million and whole continents shuffle, and what was high can be seabed. So yes, mountains will outlast us by a long stretch, and they'll stand through languages and cities and the maps we drew. But not forever. The earth will cool and its plates may slow, and before that, the sun will grow brighter, and the oceans will thin, and the great tools of erosion will change. In around 5 billion years, the sun swells, and the world we know is gone. Even rock bends to time. Maybe that's the point. Permanence isn't the measure. We're part of the same moving story, and for our moment, the mountains stand with us. Do rivers move because time does? I want to say yes, because everything happens in time, but that isn't quite right. A river moves because the ground drops and gravity pulls water downhill. The pull gives each drop direction, and friction and the river's shape set the speed. So seconds pass, but the cause is the slope and the force. Time is just the order of events. If time stopped, nothing would move. But that would freeze light and thought as well. So it isn't a push. It's the way change shows itself. Think of a marble on a tilted table. It rolls, not because the clock is ticking, but because there's a difference in height and gravity turns that into motion. A river is countless drops under the same pull. The water starts high with stored energy, and on the way down it gives that energy to the world as sound, a little heat, and worn stone. That's why valleys widen and deltas grow. We feel something similar in our lives. We don't move because time drags us. We move because differences call us, from hunger to food, from question to answer, and we spend energy to cross them. So do rivers move because time does? No. Rivers move because the world has uneven energy, and gravity lets it fall, while time is the simple fact that one moment follows another. How slow does time feel to a glacier? A glacier moves when no one's watching, and its clock is set by weight and winter, not by seconds. Snowfalls are buried and is squeezed into ice, and under its own weight, the ice creeps downhill. It isn't still, it's just slow enough to hide in plain sight. Some glaciers shift a hand's width in a day, some a few steps, and some pause, then surge. A flake that landed on a ridge can take centuries to reach the valley mouth, so a human lifetime fits inside a short stretch of that journey. Houses go up and fall down, while the same band of ice slips past a single bend in the rock. So how slow does time feel to a glacier? It doesn't feel, but its clock would count changes, not seconds. A storm is a flicker. A summer is a pulse. A century is one long push. Rocks grind to powder. Valleys deepen by the thickness of a book. Then another, then shelves. Ice even keeps a record in its own body. Tiny bubbles trap old air and layers stack like pages, each page a winter. Read from top to bottom, that spine holds thousands of seasons. Time for a glacier is the distance from snowfall to meltwater. It's the steady drag from bright snow to dark melt, measured in layers and in loss of height. Does the Earth ever rest? It's easy to think it does, because the ground can feel steady and the stars seem fixed. But the Earth is in constant motion. It turns once each day, and it circles the sun each year, and the whole solar system sweeps around the galaxy, and the galaxy drifts through space as well. So if we ask for a place to be perfectly still, there isn't one. Rest is about what you compare with what. You can sit at rest in a train seat while the world slides past, and it makes sense because you chose the seat as your reference. The same trick works for planets. We can call the Earth at rest for a map, or for a launch, or for a lesson, and it helps us think. But against other ways of measuring, it's always moving. Even the parts that look still aren't truly still. Rocks vibrate with heat. The oceans rise and fall under the moon's pull, and the air is forever trading places. Plates creep a few centimeters each year, and the planet rings with tiny waves after every storm and quake. Even against the oldest light in the universe, Earth is rushing. So no, the Earth doesn't rest. It only shifts which motion we notice, and that shifting is what gives us day and weather and the long measure we call time. Could time exist without sunlight? We learn time from the sky because the sun rises and sets and shadows move. So it's easy to think time depends on sunlight, but it doesn't. The sun is just a bright clock hung over Earth, and clocks can be made from anything that changes. Time is the ordering of change. One thing happens, then another, and the gap between them is what we call time. A pendulum swings in darkness. A lump of uranium slowly sheds energy. A cesium atom flips between states with astonishing regularity, and that's our best clock. None of these need sunlight, and the universe keeps score even where no star shines. Far from any warmth, planets still orbit, pulsars still beat, and an astronaut's pulse still ticks. Relativity says time is woven into the structure of the world, and gravity and speed can stretch it or squeeze it. Light helps us compare distant clocks because it carries signals, but time itself isn't built out of light. There's a deeper puzzle though. If nothing changed at all, anywhere, would time still be there? It would be hard to tell because there'd be no before and after to notice. But in our universe, there's always motion, always a little jitter in matter and fields, so the sequence never stops. So yes, time would exist without sunlight. Sunlight just makes the ticking visible to us. Do fossils keep time for the dead? Not like a clock with hands, but they do hold time in a way that can be read. A fossil is a body turned to stone, and it sits inside rock that built up, layer on layer. So its place is already a clue, because deeper layers were laid down earlier. And some layers carry special markers, like ash from a distant volcano, that acts like a stamped date. There's another kind of time hidden in the atoms. Some atoms in rocks are a bit restless, and they change at steady rates. Carbon that fades in younger things, or uranium that turns into lead in older rocks. So if we measure what's left and what it became, we can work out how long it's been since that shell or bone was sealed away. It's not guessing. It's a slow, reliable tick written into matter. So do fossils keep time for the dead? The dead don't need time, but fossils keep time for us because they let us place a life inside the long story of Earth. A fish in desert sandstone tells of an ancient lake. A hominin jaw beside a thin band of ash fixes a moment in our own line, and that makes deep time feel solid, not vague. In the end, a fossil is a timestamp carried by stone that lets a vanished day meet a present mind. How old is the ocean? The tricky thing is, the ocean doesn't have a single birthday. Earth formed about 4.5 billion years ago, and it was hot, and it leaked steam from young volcanoes. As the surface cooled, that steam fell back as rain, and some of it stayed. Tiny ancient crystals show that liquid water was here by about 4.4 billion years ago, which is astonishing. But big impacts came and went, and they could boil seas dry, so the first oceans may have formed, vanished, and formed again. So, how old is the ocean we know? A good answer is around 4 billion years. By then, Earth had settled enough for long-lived seas to spread and stay. And since then, the ocean has been moving through a slow machine. Water falls as rain, runs to the basins, sinks and rises with heat, and even cycles into the rocks and back out through vents. It's the same ocean, but always being remade. There's a stranger thought. Much of the water itself is older than Earth. Hydrogen was born in the first minutes after the Big Bang, and in cold space, dust grains stitched hydrogen and oxygen into water ice. Some of that ice rode in on early asteroids and mixed with water from Earth's own steam. So the ocean is ancient and always new. About 4 billion years in place, holding water that remembers a time before the sun. Will the stars ever stop shining? Not soon, but yes, one day the stars will stop. Stars shine because gravity squeezes their cores, and that pressure lets atoms fuse, and fusion releases light and heat. But fuel runs out. The sun has around 5 billion years left, then it changes and fades. Small red stars last much longer, trillions of years, because they burn slowly and use almost all their fuel. So the glow thins out, star by star. New stars are born from clouds of gas, and that's why the night is full today. But the gas gets used up and scattered and trapped in dead stars. So after about 100 trillion years, starbirth in most places will end. The sky won't go black at once. White dwarfs will cool for ages and become dark. Neutron stars will keep their heat and then lose it. Black holes will sit for an almost unthinkable time, and even they will slowly leak away and vanish. There may be rare sparks when remnants crash and light flares for a moment, but the long trend is toward darkness and toward energy spread thin. So the answer is yes. In the far future, the stars will stop, and that makes this bright chapter feel precious because we live in the universe while it still shines. Does gravity keep time moving? It's a tempting thought, because where there's mass, time behaves differently. But time doesn't need gravity to tick. Even in empty space, far from every star, a clock would keep counting seconds, because time is part of the stage, not a machine that needs winding. Gravity doesn't drive time, it bends it. Put a clock near something heavy and the seconds stretch a little, and far away they pass a bit quicker. That sounds odd, but we see it. GPS satellites run fast compared to clocks on Earth, and we correct them, or maps drift. Stand on a mountain and, over a lifetime, you age a tiny bit more than in a valley, because you're higher in the field and your seconds are slightly longer. So does gravity set the arrow of time? Not by itself. The arrow comes from the way disorder grows. Heat spreads, stars burn fuel, eggs don't unscramble. Gravity helps because it pulls matter together and makes places where energy can be used and thrown away, and that pushes the universe toward more possible states. But the forward push is this rise in disorder, not some hidden gear inside gravity. So gravity doesn't keep time moving. It shapes the rate we live it at, and it helps choose which moments can happen. And that's enough to feel the weight of being here. How long will it take for Earth to fade? It depends on what we mean by fade. Planets don't switch off at once, they thin out in time. As the sun slowly brightens, the balance of light and air and water shifts. In about 1 billion years, the oceans thin to steam, and water leaks to space. Complex life can't cope with that heat, so forests and animals end long before the rock does. The world is still there, but it's a dry shell. Simple microbes might hold on in shadows or deep rock for a while. Much later, roughly 5 billion years from now, the sun runs low on fuel and swells. Its light turns red, and the inner planets are cooked. Earth may be swallowed, or it may be stripped to a cinder and left to drift cold. Either way, the blue fades into stone, and then the stone fades into dust. And there's another sense. Languages go first, then buildings, then names. Fossils last, and then they're ground down by time. So Earth doesn't fade once. It fades in layers. Life fades in about 1 billion years, seas soon after, the surface under a swollen sun a few billion later. The idea of Earth lasts as long as minds remember, and that clock is ours to wind. Is extinction part of time's rhythm? Every species has a beginning and an end. In rocks laid down like annual pages, we see names appear, spread, and vanish. Some slip away as coastlines move and climates lean one way, and some disappear in sudden shocks when the world is struck or the air turns sour. There's a steady background beat where change nudges species out, and there are rare crashes when many go at once. So is that time's rhythm? In a blunt sense, yes, because time is change, and change retools the world. Continents wander, seas open and close, stars flare and send energy that folds weather. So habitats shift, and the fit of living things stops fitting. Extinction prunes the tree, and evolution grows new shoots into the spaces left. That loss hurts, but it makes room for novelty, and that's why the world has chapters at all. We're not outside this. We've sped the rate by moving species, cutting forests, and heating the air. But we're also the first to see the pattern and plan. We can protect space, rebuild links in food webs, even deflect rocks from space. Even on longer scales, Earth will change. The sun will swell, and the oceans will go. So extinction isn't a glitch, it's a feature of time. What's new is that we can choose how long the living world keeps its place in the song. Will nature ever start over again? Things break, forests burn, stars die, and we wonder if nature ever presses a reset. On Earth, the record says no and yes. There have been great die-offs, and each time life didn't rewind, it kept going with whatever survived. New branches grew because the old ones cleared space, and the world changed its rules a little. So, start over isn't a button, it's a handover. The same pattern runs in the sky. A star uses its fuel and collapses, and in the wreckage new stars form. They're richer because the first star made heavier stuff, so planets can form, and chemistry can get busy. So the next round begins, but it isn't the same round. Time has a direction, and ashes aren't the same as the tree, even if they feed one. There is no perfect reset because the universe keeps a kind of memory. It's in the elements, in ice layers, in fossils, and in the ways creatures learn to live. And we sit inside that memory. We rebuild after floods and wars, and we carry the scars and the skills, so our again is never a copy. So will nature start over? It will start again many times from what remains and what it has learned. And that's enough for new worlds to begin. How long is forever for the planet? Forever sounds endless, but planets run on the clocks of their stars. Earth has been here for about 4.5 billion years, and the sun is about halfway through its life. Stars slowly grow brighter as they age, so the rules on the surface shift. At first it's a whisper, and then it's a push, and in something like 1 billion years, the oceans thin and vanish, and complex life can't keep going. The planet won't be gone, but the part that feels like a world to us will be. Carry on a few billion years more, and the sun swells into a red giant. It may swallow Earth, or strip it to a dark, melted core that circles a fading star. After that, the sun becomes a white dwarf, a hot ember. If anything of Earth remains, it drifts as a silent relic. So as a home for life, forever is maybe 1 billion years. As a piece of rock, it's perhaps 5 billion more. As matter, if it survives, it could wander for ages beyond counting. And human time sits inside that. A lifetime is a tiny line on a vast clock, but it's drawn in the only place life can speak. So forever, for this planet, is long enough to change and short enough to matter. Is there an end to natural time? We measure time by watching things change. A heart beats, a planet turns, light crosses a room. So the question hides another one. If nothing changed anymore, would time still be there? The universe is expanding, and the energy in it's thinning out. Stars burn their fuel and fade, and black holes will swallow and then slowly leak their contents away. Over unthinkable stretches, the busy traffic of events becomes a few rare clicks, then almost none. You could still keep the numbers ticking on a clock, but if nothing in nature can set a rhythm, the idea of time starts to feel empty. Could there be a hard stop? Maybe if expansion tears everything apart, or if it turned around and crushed everything together. Right now, the measurements say expansion is speeding up, so a long fade looks more likely than a crash. And at the very end, our current laws go quiet, so we can't be certain. But there's a clearer edge closer to home. Our lives end. Our sun will end. Our planet's cycles will end long before the cosmos cools. So does natural time end? For us, yes, many times over. For the universe, it doesn't end so much as it runs out of things to count. Could time ever stop completely? It's odd to ask if time could ever stop, because the clocks already disagree. A watch on a mountain runs a touch fast, and one by the sea runs slow. So time isn't one setting, it's a web of ticks tied to motion and gravity. Could that web snap? You can slow time almost as much as you like. Move close to the speed of light, and your seconds stretch. Stand deep in a strong gravitational field and your clock lags. But for you, it never reaches zero. From far away, a clock falling toward the edge of a black hole seems to freeze. Its signals take longer and longer to arrive, and it fades. But on the way down, its own seconds still come, and they run out at the center. That's not time stopping. That's a journey finishing. Could time stop everywhere at once? That would mean nothing at all could change. No atoms twitching, no light crossing space, no tiny jitters in empty space. Turning off all change seems beyond nature's rules. Even in the far future, when stars are gone and energy is thin, there will still be rare flickers. So, could time ever stop completely? It can slow, and it can end along a path, but a perfect freeze doesn't seem to exist. What happens after the last second passes? It depends whose last second we mean. For a person, the last second is the end of experience. The brain stops building the pattern that holds a self, and there isn't a next moment to notice. So from the inside, there's no after, because noticing needs a working mind. But from the outside, the clock keeps going. Air still moves, the streetlight stays on. The earth turns. Your atoms carry on as matter and heat, and your choices keep working through other people like a signal that hasn't faded yet. Because that's the other kind of after, the one that lives in memories and habits and stories. Someone cooks the way you taught them. A road you helped build still carries buses. A kindness you gave shifts a decision far away, and you'll never know. But it happens. And what about the last second of the universe? If time itself ended, there wouldn't be an after at all, because after is a piece of time. It may not be a hard stop, though. It could be a slow emptying, where differences even out until nothing changes enough to count a second. In that case, the question dissolves with the clock, so the last second closes a life from the inside and leaves a trace in the world. The last second of time would end the question itself. Will the universe keep expanding forever? We already see it happening. Space is stretching, and the light from distant galaxies is pulled thin as it travels, which tells us they're moving away. And not just moving, the expansion is speeding up. So the real question is, what's pushing on the empty parts of the universe? We call it dark energy. It isn't a thing we can hold. It's more like a pressure built into space itself. If that pressure stays the same, then the expansion doesn't slow. It keeps going, and the big structures drift apart. Our local group of galaxies stays together because gravity wins nearby, but everything beyond slips over a horizon and fades from view. Could it turn around? That would need far more matter than we see, enough to pull everything back. The numbers don't point that way. Could it end in a rip? Only if the pressure grows stronger with time, and the best measurements say it's steady, or very close. So the long story is simple and strange. Stars keep burning, then thin out, and the night sky empties. Black holes outlast the stars, then fade as well. The universe cools and grows wider without edge, which means the expansion looks endless, and our bright little island stays local while the ocean runs on. Can there be life without time? We call something alive when it grows and uses energy and responds. And each of those is a change that needs a before and an after. A cell copies DNA step by step. A heart fires, then rests. Food breaks down and builds new parts. If there's no time, there's no sequence, so causes can't lead to effects. Chemistry freezes. Nothing can adapt, or heal, or choose. But there's another way to look. Maybe time is like a dimension, laid out with space, so every event already sits in one great shape. In that picture, a life is a long thread running through the block. The birth, the meals, the messages, the last breath, all there at once. So could that count as life without time passing? It would be a perfect pattern, but it wouldn't be doing anything. Because living isn't just the shape, it's the running of the steps from earlier to later. And that's what being human feels like. Memory leaning back, hope leaning forward, the present held between them. We learn because moments aren't stacked on top of each other, they flow into each other. We love because we have a past together and a plan. So life without time would be like a book with every page glued together. The whole story exists, but no one can read it. What will exist when time is gone? It's an odd place to stand, because when is built from time. And if time has gone, the word slips out of our hands. But we can still ask what would remain if change itself stopped. Time is our way of keeping track of change. Clocks tick because atoms move, hearts beat, stars burn. If nothing changed, there'd be no ticking at all. So if time ends, what's left isn't an empty moment. It's a finished shape. Think of the universe not as a line that runs, but as a whole map of everything that ever happened. Every birth, every sunrise, every star that lit and faded, set in relation to everything else. If the running stops, the map doesn't vanish. It just isn't running. It simply is. People talk about the far future, when stars die and even black holes fade. In that reach, nothing happens for longer than any clock can say. But the laws that tied things together still hold, and the total story they allowed is complete. And our lives are written into that shape. So what exists when time is gone? Not a next thing, not a later, the full thing. The structure of relations that made a world, with every change held in place. Like a finished song that no longer plays, but still exists. as itself. Could something start after time ends? It sounds like a trick. If time ends, what could after be? After is a time word, so if the clock stops, there is no after. It's like asking for the next page when the book has no more pages. But there's a way to think about it. A clock can stop in one room while others tick in the house. So an end can be local. Inside a black hole, some paths end, but the wider universe carries on. And that shows how after depends on which clock you trust. Now imagine the whole universe reaches a final state where nothing changes. If time is change, then the end is just the last change. After that, words like before and after don't stick to anything because there's no difference to count. So, in the strict sense, nothing can start after time ends. But maybe time isn't basic. Maybe it's something that appears when things move and interact. If those ingredients reassemble in a new way, a new time could appear, not after hours, but with its own arrow and its own way of counting. So could something start after time ends? Inside the ended time? No. In a larger reality that allows another clock, a start could happen, but not after, only anew. Does time ever repeat itself? Clocks repeat the same numbers every day, but that isn't time repeating. It's just the dial going round. A moment doesn't come back, because the world has moved on in ways you can't rewind. Heat has flowed, light has travelled, choices have knocked into other choices. There's a rule underneath this that gives time its direction. It's called entropy, and it's just how spread out things are. Drop a bit of ink in water, and it spreads. Scramble an egg, and it doesn't unscramble. The spread grows, so the future isn't the same as the past. Now, in a tiny sealed world with only a few possible arrangements, the pieces could wander for an absurdly long time and land close to where they started. Like shuffling a small deck until an old order turns up. But our universe isn't small. New stars light, old stars die, space itself stretches, and the number of ways matter can be arranged is beyond counting. Exact repeats aren't just rare. They're buried behind time so long they don't fit into a life or a galaxy, or even the ages of the cosmos. And yet we feel repeats. Birthdays, seasons, songs that bring back a face. The pattern returns, but we're not the same, and neither is the world. So time doesn't loop like a track set to repeat. It writes, and once a line is written, it stays written. Can the future already exist? It sounds strange, because the future is the part we haven't lived yet, and it seems open. But when we look at time the way we look at space, a different picture appears. Einstein showed that time is stitched to space, and people moving in different ways don't agree on what counts as now. If there isn't one single universal present, that hints that every moment is part of one laid out structure, like a map we cross rather than a path being drawn. So why don't we remember tomorrow? Because there's an arrow in the world. Heat spreads, cups shatter, and records build in one direction. We carry traces of what has happened, not of what will, so experience runs from memory into uncertainty. The future can still be there in the structure, but information from it hasn't reached us. And at the smallest scales, outcomes aren't always fixed ahead of time. A particle can land here or there, and only a result appears when it interacts. That may mean the map includes branches, or it may mean we just see one line through it. Either way, from inside a living moment, it feels like choice. So, can the future already exist? It can, as part of the world's geometry, while still arriving to us as surprise. Will time ever run out of space to move? It's a sharp question, because it imagines time as a traveler looking for a road. But time doesn't move. Change moves, and time is how we count the steps. Space isn't a container that time crosses. They're joined as one thing. So the real question is whether the universe can run out of change. So what would that look like? Stars burn through their fuel and fade, and black holes swallow and then evaporate, and the space between everything keeps stretching. Energy spreads out. Clocks need differences to tick, like a hot side and a cold side, or motion against something still. If the universe becomes almost even everywhere, there's nothing left to drive a tick. Time is still part of the world, but it loses events. It's like a song held on one long note. Not silence, but no melody to count. There are other endings. The whole universe could collapse and end time in a final crunch. Or the stretching could tear everything apart so fast that time stops at a finite moment. But what we see points to a slower fate, where expansion continues and change thins out, and that loops back to us. We feel time through heartbeats and sunrises and choices. So no, time won't run out of space. It may just run out of things to do. Could the end of time feel peaceful? I think it depends on what we mean by the end of time. Time, for us, is the way change stacks up. Before, then, after. We feel it in heartbeats and in the way a day turns into evening. If, at the far end of the universe, change runs out, there's nothing left to stack. The clocks could still exist, but they'd have nothing to count. Some ideas of the future say stars fade, matter spreads thin, and energy differences even out. Without differences, nothing happens. And if nothing happens, there's no sequence to sit inside, and no mind to notice it. For any beings still around near that horizon, the feeling wouldn't be a sudden stop. It would be a long slowing. Signals take longer. Fuel is harder to find. Memories stretch between wider gaps. The world would have less push and pull, and choices would arrive further apart. Would that feel like rest? Maybe. Not because the cosmos is kind, but because urgency is a product of change, and urgency would be running out. But the very end itself can't be felt, because feeling takes time. It needs a before and an after to compare. So if there is an end of time, it isn't an experience. It's the moment experience no longer has anywhere to happen. If everything froze, would we notice? Say the whole universe stopped between two heartbeats. Every clock stuck, every atom held, light hanging in mid-air. The signals in our brains paused mid-spark. There's nothing to see in that pause, because seeing needs change, and change is off. Noticing is also a kind of movement, and that movement is frozen too. So when everything starts again, what would we remember? Nothing at all. There'd be no mark to find. Memory is just matter rearranged. And if nothing rearranged during the pause, there's no gap to record. The story would jump from one instant to the next, and we'd feel it as a single, smooth moment. But what if only some things froze? If the world stopped and we didn't, we'd need air to move, and light to reach our eyes, and energy to run our thoughts. If the air was fixed, we couldn't breathe. If light was pinned, sight would vanish. To notice a pause, at least one thread must keep going while another holds still. That's the rule. It's the difference that makes an event. And because we're part of the same universe we want to test, we share its stop. So the strange answer is no. A frozen universe has no time inside it, because time is just the count of change. When the count resumes, life feels continuous, and we carry on. Will memories still exist when time stops? Start with the easy part. A memory is a physical pattern. It's the wiring of neurons and the strengths of their links and the traces they leave in a living brain. So if the universe were caught in a single freeze frame, that pattern would be there. Like ink on a page, the shapes don't vanish just because nothing moves. But memory isn't only a shape. It's a shape that does something. It has to be written and read and used to predict the next moment. That needs before and after. So if time truly stops, there's no writing and no reading and no next. The pattern remains, but the act of remembering is gone, and there's a deeper twist. We call something a memory because it points beyond the present. It's a bridge between moments. Without moments to connect, a bridge hangs over nothing. It still has structure, but it doesn't carry anyone anywhere. In our universe, clocks can slow near great gravity, but they don't reach zero for the person falling. Time stopping everywhere is not a thing we expect to see. Still, the thought is useful because it shows what memory really is. It's matter shaped to reach through time. Take time away, and the shape stays, but the reach can't happen. So if time stops, memories don't die. They just can't be memory. Is there a moment after the last moment? I keep turning this over. We say last moment like a final tick on a clock. So is there a tick after that? If the clock is the thing that makes ticks, then no, because the clock has stopped. After only makes sense while the ticking goes on. For a person, the last moment has no label inside, because the brain that would mark it is also switching off. There isn't a felt edge, there's just a final frame that never gets filed. So for the person there is no next, and there's not even a clean, this was the last. For everyone else, time carries on, and they put the label on that moment from the outside. For the universe, the question gets sharper. If time runs forever, there's always another thin moment, colder and slower, and no last at all. But if time really ends, if the machine that allows change has no more fuel, then asking what comes after is like asking what's north of the North Pole. The word after needs time to stand on, and that flaw would be gone. So is there a moment after the last moment? Only in a larger story that keeps running. Inside the thing that ends, there's an edge, and beyond the edge, there isn't a place for moments. Does time end the same way it began? It didn't begin like a sunrise. It began when the whole universe was squeezed into a hot, dense state, and the word before didn't make sense. Time took shape as the universe expanded, because change had room to happen. And there was a direction built in, from a strange kind of order toward a richer mix of possibilities. That direction is why cups break and don't unbreak, and why our memories point one way. So how might it end? One picture says the universe keeps expanding. Stars burn out, and matter thins into a faint, even mist. When nothing much can change, time still exists on paper, but it loses its grip because there's nothing left to mark it. Another picture says space could tear itself apart faster and faster, until even atoms can't hold. A sharper ending would be a sudden switch in the vacuum of space, a new rule spreading at light speed, wiping the old story clean in an instant. None of these look like the beginning. The start was tight, hot, and oddly simple. The most likely end is wide, cold, and indifferent. And in between are our small clocks, our lives, measuring a universe that began with a spark and may finish as a whisper of change. Will eternity ever get boring? Eternity sounds like a long corridor, and we worry that every door would start to look the same. But boredom isn't in time, it's in minds. It's a signal that the world isn't giving us enough difference, or that we've stopped noticing what's there. So the answer depends on what can change, and on whether we can keep changing with it. If forever meant the same day on repeat, then yes, the colors would drain. Our brains adapt because repetition turns surprise into background noise. But if forever includes new stars, new questions, new ways to think, then the supply of difference isn't fixed. Meaning tends to live at the edge of what we can handle, and that edge can move. There's a harder thought. The universe is spending its fuel. Stars burn out, and everything spreads thin. Far enough ahead, there may be almost nothing left to light a mind. If eternity extends beyond that, boredom becomes the wrong word, because boredom assumes the energy to care. So will eternity get boring? Only if growth stops. If minds can deepen, if values can widen, if attention can learn to see finer detail, then time keeps opening. And even if there's an end to novelty out there, there's still the wonder that it lasted long enough to ask the question. Can time forget itself? It starts as a strange question, because forgetting belongs to minds, and time has no mind. Time is just how we count change. Seconds and hours are labels on motion, but records do exist, and they live in matter. They're the marks the past leaves behind. Scars on skin, rings in trees, light from distant stars, and patterns in our brains. And as the world wears and spreads out, that's entropy. Records blur. A chalk mark gets smudged, a footprint in snow softens and vanishes, and the room where something happened looks the same as any other room. On the biggest scales, the universe does this too. Black holes swallow detail and later leak a thin glow. Many think the details aren't destroyed, just scrambled into the glow so cleverly we can't recover them. And far ahead, when the last stars fade and heat evens out, there may be almost nothing left to record anything at all. So can time forget itself? Not really. Time never remembered. But the universe can erase its own notes until past and future feel the same, because nothing keeps score. We keep score. Our memories, our fossils, our photos are small arrows that make direction real for us. And as long as something keeps a record, time has a face. Will we ever reach the end of time? It sounds natural to ask if time ends, because stories end and days end, but time might be different. We meet it as one tick after another, and we're carried along, so it feels like a road that must have a last sign. The universe had a hot, dense beginning, so there was a first chapter for our kind of time. What about the last? One path says the cosmos keeps expanding, faster and faster, and stars burn out, and black holes fade, and the gaps grow wider. Time would still run, but there'd be almost nothing left to change. No final bell, just fewer events, like a signal dying into noise. Another path says space could tear itself apart in a single rush, a big rip, where every bond gives way. That would be a true end, a last moment for clocks. It's possible, but the signs we have point more toward the long thinning rather than a sudden break. And yet there's a second meaning. Will we reach the end of time? For us, our lives are brief, and our own time ends. That's why the middle matters. We build, we love, we ask questions, because we can't hold the seconds still. So the end of time is either a wall no one touches, or a horizon that keeps retreating, while we make meaning here between ticks. Is time a cycle or a straight line? Clocks go round and seasons repeat, so it's easy to think time runs in circles. But memories stack in one direction, and a dropped glass shatters and doesn't fix itself, so it also feels like a road. So which picture holds? Cycles are the tools we use to count. The earth turns and gives a day. It goes round the sun and gives a year. Atoms tremble in steady beats. Those are repeating motions in space, and time is the tally they mark. The repeat is in the clock, not in time. What makes time feel like a line is the one-way spread of change. Heat leaks from hot to cold, smoke mixes with air, order loosens into disorder. That steady drift is called the arrow of time, and it points from past to future because the universe began in a very ordered state, and it's been unwinding ever since. Could time itself loop? The shape of space and gravity might allow paths that curl back, but there's no sign that nature lets us ride them. And the universe is still growing wider, so there's no clear grand cycle to close the loop we're in. So time holds both ideas at once. We measure it with cycles, and we live it as a line, like hands going round while the calendar turns. Can something be truly timeless? We call a song timeless, but records warp and voices fade. So what do we mean? Timeless sounds like not changing when time passes. And that's hard inside a universe where time isn't a stage outside the play, it's part of the set. Anything that exists here moves with it. Stars burn, mountains drift. Even the patterns in our brains shift from moment to moment, because change is what time measures. So maybe the only candidates aren't things at all, but relations. 2 plus 2 makes 4 in any era. The circle's edge stays per times its width whenever a circle is a circle. And if the rules of nature don't change from today to tomorrow, then certain totals stay fixed, like energy in a closed box. These feel steady, not because they sit beyond time, but because their truth doesn't care about when. When we call a story timeless, we mean it keeps working across lives. It survives because its pattern fits. Minds built to seek connection and fairness and hope. It's endurance through change, not escape from it. Could there be a state that's truly outside time? That would be a world with no change at all, and nothing could happen there. So the closest we get is structure. Everything else is time-bound, and that's where meaning appears. Could we ever live outside of time? Start with an idea. Time is change. One thing happens, then another, and that order is time. So to live outside time would mean being alive with no change at all. But life is made of change. Hearts beat, cells trade energy, thoughts flicker and fade, and each step is a small tick. We can bend time though. Speed and gravity can slow your ticking compared with the world. Astronauts come home younger than the clocks they left behind. Near a black hole, years could pass elsewhere, while minutes pass for you. But you still move from one moment to the next. You're not outside time. You're just taking a different route through it. Light goes further. For a beam of light, there's no time between being launched and being caught. But light doesn't have a life to live, and we can't become light and stay ourselves. People dream of freezing a body to jump to the future. That's a pause, not a life outside time. The story skips a chapter, and there's no awareness in the gap. Some think all moments exist at once, like pages in one book. It's a striking picture, but seeing every page still takes a sequence. So no, we can't live outside time. We can only shape our time and leave traces that outlast us. When everything stops changing, what's left? If everything stopped changing, would time still pass? We tell time by change. Hands move, hearts beat, shadows slide. And that's how we know a moment has gone. So if nothing shifts at all, there's no before and after that we could point to. In the far future, some say the universe may end like that. Energy spreads so evenly that nothing can happen, because there are no differences left to drive a process. Physicists call that heat death, but it just means a world with no work to do. No spark, no fall, no climb. A flat signal. So what's left? Not events, not stories, maybe only the rules, the simple relations that say how things would change if they could. and a smooth kind of sameness, the same everywhere, with no marking of time. It matters for us because being alive is made of change. Thoughts fire, proteins fold, memories grow and fade. Take change away and the light inside a mind can't switch on. Even the word left depends on a difference between now and later, and that difference has gone. So when everything stops changing, what's left is a still symmetry, and the fact that there is something rather than nothing. And it shows why change isn't just noise in the background. It's the thing that makes time, meaning, and life exist at all. Will the stars still burn in frozen time? If time really froze, nothing would move, not even light. A star only burns because tiny particles meet and fuse, and that takes moments ticking by. Hydrogen becomes helium, and energy spills out as heat and light, and the surface flickers, and the core breathes in pressure, and all of that is change. So in truly frozen time, the star is a picture, beautiful but silent, no burning at all. But time isn't one thing everywhere. It runs at different rates depending on gravity and speed. Near a black hole, a clock crawls compared to ours, and a distant star can seem to hang. From far away, it looks slowed, almost paused. Yet, in its own time, the star lives as normal. It burns, ages, and ends, because for it the seconds still pass. There's another sense people mean, the far future, when the universe thins and cools. That isn't frozen time. That's time with nothing left to do. The fuel runs out, the fires fade, and the night grows wider. We want to freeze the moments we love, but life, like starlight, needs time to make anything happen. Thought needs it. Memory needs it. Meaning needs it. The stars burn only while time moves, and so do we. Could the future loop into the past? Time feels like a one-way street because heat spreads out and cups shatter and memories point one way. So we ask, could it ever bend back? The maths of gravity does allow strange paths where a traveller could leave, circle through time, and arrive at an earlier day. They need extreme conditions, like a spinning black hole or a shortcut tunnel we call a wormhole. But when we try to make them stable, energy blows up and quantum noise shakes them apart, so nature may block the loop before it starts. And even if a loop existed, the past inside it couldn't be free to change. To avoid paradox, every event on the loop would fit together, like gears that only turn one way. You wouldn't rewrite your history, you'd complete it. The future you would be part of the same story that always made the past you. So does the future reach back? Not in a way that breaks cause and effect. The arrow we live with comes from disorder growing, and that keeps records in the past and guesses in the future. But there is a smaller loop we live by. The future we imagine pulls on us now, and our choices today become the past we leave behind. That's the loop that matters for beings like us. Can silence exist without time passing? Silence is a strange thing, because we only notice it when it lasts. You hold your breath, and the room holds still, and you wait, and nothing comes. That stretch is the silence. It's not a thing in the air. It's the gap in a stream of changes. Sound is air, rising and falling. Tiny pushes arriving one after another, and your ear and brain need a little time to feel those pushes. So to have no sound, there has to be time for nothing to happen. What if no time passes at all? Then there's no before and after to compare. There's no wave crossing the room, and there's no gap either, because a gap is a length. A single frozen instant can't carry sound, but it can't carry silence, because silence is a held absence. It's like stopping a film on one frame. You don't see a pause in the story, you just see a frame. So the answer is that silence can't exist without time, not in any way that matters to a listener. We can name a timeless silence, but we can't meet it, because meeting needs duration. The only way silence becomes real is by lasting, even if it lasts for the blink of a thought. Does time ever rest between moments? It's tempting to think time moves in clicks, like frames of a film, and there's a gap where nothing happens. But if there were gaps, motion would stutter. A thrown ball would freeze between frames, and we never see that when we look closely at how things move. Our best math treats time as a smooth line, not a staircase, because that's the only way cause and effect stay locked together. At the tiniest scales we can imagine, there's a number called the Planck time, so small it's about a decimal point and 43 zeros before a 1. Below that, our math stops being clear. Some people imagine that as a minimum tick, like the smallest beat the universe can play. We don't know if that's true. And even if nature had such ticks, nothing would sit in the crack between them, because between wouldn't exist there. What does have gaps is us. The brain collects signals and bundles them into moments, often about 1/10 of a second. That's why a spinning spark becomes a circle, and why we can miss a word and still follow the sentence. So the pause we feel isn't time resting, it's attention resetting. Does time ever rest between moments? Not in any way we can find. If there's a rest, it's in us, while the world keeps its thread unbroken. Is death the same thing as running out of time? The heart has been counting since before we were born, and one day it will stop. So is death just running out of time? It's close, but not quite. Time doesn't belong to us. It keeps going whether we're here or not. A day on earth carries on after a life ends. So death isn't time ending. It's a body letting go of the pattern that could use time. We're made of small parts that fix and power one another. When we're young, repairs outrun damage, and the signal holds together. As years pass, the errors add up, and the repair crews tire, and the rhythm slips. At some point, the system can't keep the pattern. The heart stops, the brain falls silent, and the signal drops out. Time still flows. The clock hasn't paused, but our ability to change with it has. So, running out of time fits how it feels inside a life. We have a limited budget of moments to spend. We choose, and we trade one path for another because there won't be endless chances. That limit gives meaning shape. Without an edge, a picture never forms. In that sense, death isn't a thief of time. It's the boundary that makes time into a life. Death isn't time stopping. It's our signal falling to zero while the clock keeps ticking. Could time be dreaming right now? It's a strange thought, that time could be dreaming. Because dreaming needs a mind, and time isn't a mind, it's change kept in order. When things move, cool, grow, and fade, we call that the thread of time. So in that strict sense, time can't dream. But the question points at something real. The world doesn't hand us time like a pre-cut tape. Our brains build the sense of before and after. We store memories, we guess what's next, and the present sits like a thin edge between them. So the dreamy part may be us. And still, the universe isn't rigid. Time can stretch and bend. Clocks slow on fast rockets and near heavy stars, and they tick faster up on mountains. So there's no single master clock laying down an iron beat. Each path through space carries its own tempo. On tiny scales, outcomes arrive as a spread of chances until an interaction picks one. The future isn't written, it's offered. Could time be dreaming then? Not as a mind would. But it does allow many ways a story can go, and we ride one of them. We feel a smooth signal, because our brains stitch scattered frames into a line. Time is the stage built from change, and we're the storytellers crossing it. That's why the question stays with us. Will there be another beginning after the end? Endings look final. The door shuts. The sound stops. But if you keep looking, the world keeps moving. When a star dies, it throws its matter into space, and that dust becomes new stars, planets, and people. So one end feeds many beginnings. In us, endings make space. A habit breaks, and room appears for a different day. A life ends, and love doesn't stop. It turns into stories and choices in the people left behind. That's real, not poetry. Now the big end, the universe. Right now, it seems to be spreading out and cooling. Energy is getting thin and mixed. That's entropy, useful energy turning into a background that can't do much work. If that keeps going, stars will burn out, and the night will go dark. That could be the end of making new things. Could there be a reset? Maybe space keeps spreading until almost nothing happens. And then, from a tiny random shake in energy, a new expansion begins. Or the universe could bounce, so a collapse becomes a new birth. Or it may never reset at all. We don't know, and that uncertainty is honest. But we do know this. Beginnings sit inside endings already. Every stop opens a path for something else. So will there be another beginning after the end? Yes, in our lives, again and again, and maybe one day in the largest way of all. Is peace what happens when time stops? It's tempting to think peace arrives when everything freezes, like the world holds its breath. But time is change we can count. The tick of a clock, a heartbeat, light crossing a room. If time stopped, there'd be no heartbeat, no thought, no one there to notice peace. Peace feels different. It's what happens when change stops fighting us. Inside, the brain is a prediction machine. It throws lines into the next second and checks what comes back. When the world matches those lines, the alarms ease, and the body loosens its grip. So time hasn't stopped, but the friction has dropped, because life keeps moving through us while we stop bracing for it. And that feels wide and simple, like a spinning top that's balanced. It's moving fast, yet it looks steady because the pushes are even. Peace is a balance between what is and what we expect, or our willingness to let the mismatch be. It can appear in a busy street, or while working because the mind has no quarrel with the moment. So the clock keeps going, and change unfolds, and we feel held rather than dragged. Peace isn't the pause of time. It's the pause in struggle with time. Could the universe wake up again one day? It's a strange thought because there was a time with no stars and no minds, and then there was light and chemistry and awareness. So if it happened once, could it happen again? Minds need a kind of fuel, not just energy, but a difference in energy, a slope, so things can flow and do work. Stars give us that, and planets trap it, and life builds little engines that think. But stars fade, and black holes evaporate, and the expansion of space stretches everything so thin that differences smooth out. That far future is called heat death. It means nothing left to push against, so no thinking machines, no thought. There are escape routes people wonder about. Maybe the expansion could reverse, and everything fall back and start again, like a cosmic reset. But the expansion seems to be speeding up, driven by something like a steady push. So a collapse looks unlikely. Maybe chance could stitch a moment of thought from random motion, like letters lining up to make a sentence once in an endless library. It's not impossible, but it wouldn't last, and it wouldn't build a world. Or perhaps minds learn to make new universes with fresh energy slopes. If that's allowed, then awareness might continue elsewhere. And that possibility sits inside us now, as part of the universe that learned to ask. Does forever have a middle? It sounds like a trick, but it's a real question. What would a middle even mean? In everyday life, a middle is the halfway point between two ends. Fold a rope and the crease marks the center. But forever doesn't have ends. There's no last moment and no edge to lean a ruler against. So in that simple sense, no, forever has no middle. On a circle, there's no first point and no last point. We can pick a spot and call it the center of a map. But that's a choice, not the circles. An endless road works the same way. Any milestone can be zero if we decide. Time might be like that if it runs without bound. Now can feel like the middle because we remember a stretch behind and imagine a stretch ahead. That's how a life feels, with memory behind and hope ahead, and the present held like a marker. But it's our middle, not time's. And if time began, the future may still run on without end. We can move away from the start forever and never hit a halfway mark because half of endless is still endless. So the answer is simple and a little strange. Forever doesn't carry a middle inside it. We carry one for a while and we stand it up wherever we are. Could we ever feel time ending? We only feel time because something changes. A hand moves on a clock, a heart contracts, light shifts across a wall. If nothing changed, there'd be no before and after to notice. So if time truly ended, not just for us, but for everything, there wouldn't be a last moment you could feel. Feeling needs a moment to start and a moment to finish, and those would be gone. But what about an approach to an end? If the universe thins out and evens out, stars die and energy spreads, the differences that give us events would fade. Clocks need energy to tick, and minds need energy to make memories, so the world would offer fewer and fewer things to count. Time wouldn't stop like a door slamming. It would lose its grip on us, because there'd be almost nothing left that could change. Or imagine a sudden end, a hard wall in the rules. There'd be no warning to register. The last thought wouldn't complete, because completion takes a sliver of time. So the honest answer is strange and simple. We can feel time because there is change. If time ends, feeling ends with it. What we might sense is only the dimming of difference on the way there, and then not even that. Does everything that ever happened still exist somewhere? The past feels like it falls behind us and vanishes, but the way time works suggests a different picture. Space and time form one thing, so what counts as now depends on how you move, and that means your present and mine aren't the same slice. So the universe looks less like a line and more like a whole block, with every event laid out, and our minds walk a path through it. If that's true, then in one sense, the past still exists, but access is limited. We don't have a door to yesterday, but we do see its light. Starlight that reaches us tonight began its trip before our great-grandparents were born. There's a faint glow across the sky, the afterglow of the hot, young universe, still arriving. Rocks hold old seas. Trees keep dry summers in their rings. Even the air carries whispers of old fires and breaths. Does every detail remain? Not in any way we can gather. When things happen, information spreads into countless particles, as heat and motion, and it mixes until no tool can pull it back. Yet the rules of physics hint that it isn't destroyed, it's scrambled into the world. So the past isn't gone so much as out of reach. It's woven into the fabric of space and time, and into traces around us. We add a trace now. Could time be just one way of seeing reality? It changes when we move, and it slows near heavy things, so it already behaves less like a universal drumbeat and more like a reading we take from the world. Two clocks can disagree and both be right because each is telling time along its own path. So maybe time is a way we slice a deeper whole. Imagine a single landscape that can be mapped in different ways. One map shows heights, another shows roads. The ground is the same, but each map makes a different feature feel central. Time could be that sort of map. It orders events into before and after along our path through space and gravity, and if we take a different path, the order can shift a little. And our sense of a flowing present may be a construction. The brain stitches moments into a story so we can act, and it uses memory as the glue. The arrow we feel comes from change that tends to spread. Heat leaks, ink disperses, a dropped cup shatters and won't unshatter. That tilt gives us a direction to call future, even though many basic rules don't prefer either way. So yes, time could be one way of seeing reality. It's the thread that lets causes line up, and it turns a vast, linked world into a life we can live. If time ends, will cause and effect still matter? Say there is a last second, a hard stop. What happens to cause and effect? They're not magic. They're just the rule that one moment sets the conditions for the next. So they need a before and an after. If there's no after beyond the final line, nothing new can be caused. But everything up to that line still hangs together because of those links. Think of a finished track. Each plank supports the next, and the track simply ends. The support still matters, even if there's no plank beyond the last one. The laws that tie one state to the next still shape the final state, and they explain why that last second looks the way it does. And inside those final moments, time is still time. Things change. Signals travel. Causes make effects until they run out of room. If the end is a freeze, or a collapse, or a thinning into nothing much, the chain continues right up to the boundary, then stops. Could cause and effect exist outside time? No, because outside time isn't a place to stand. Without before and after, the idea has nowhere to grip. So if time ends, cause and effect still matter. They build the world to its last moment, and then they fall quiet. Could time end quietly, without us knowing? It's an odd idea, not time exploding, but time just not being there to hold the next moment. For us, time is change. A heart beating, atoms vibrating, light crossing a room. A clock is only something that changes in a steady way. So, if change runs out, time loses its grip. The universe is spending its energy. Stars burn their fuel. Black holes feed and fade. Heat spreads out. In the very far future, the differences that let things happen get ironed flat. There may still be a number we could call later, but with no engines left, no clock can tick. From inside, there's no single moment that says, this is the end. It just gets harder to make anything happen until nothing does. There's another path. Space itself could slip into a lower energy state. A bubble could appear somewhere and race outward at light speed. No warning, no pain, no chance to point and say now. The rules would change, and our story would stop between one heartbeat and the next. So could time end without us knowing? In two different ways, yes. By running out of difference, or by being replaced in an instant. And the strangest part is simple. Without change, there's nothing left that could notice. Does time have a purpose? We count birthdays and deadlines, and it's easy to feel that time wants something from us. But time isn't a mind. It doesn't aim. It's change, stacked in order, so causes line up before effects, and clocks just keep score. There is an arrow though. Heat spreads, cups shatter, smoke drifts and doesn't gather itself back. That happens because there are far more messy ways for matter to be than neat ones, so the world tends to wander into the larger set. We call that drift entropy, but it's really just the odds playing out. That's why the past is a record and the future is open. So if time has no plan, where does purpose live? It lives in living things. A seed strives because chemistry that copied itself survived, and minds rose from that slow filter. We remember, we predict, we choose goals, and we test them against what happens next. Purpose is a pattern we draw across moments, and it only works because moments come in order. That's the gift here. Time gives no instructions, but it gives a direction. It lets history accumulate and lets knowledge stick. It makes room for tenderness and repair. It doesn't tell us what to do, but it lets a meaning be made. Will there ever be a last story to tell? It's tempting to think there will be a final tale, because how many ways can we move the same pieces? But a story is less about the pieces and more about a mind noticing the world. The shapes may repeat, and the meaning shifts, because the world outside and the world inside don't sit still. New tools arrive, and they change what a person can see. New places appear, and they change what a person can feel. We grow, we forget, we remember differently, and the same event becomes a new telling. Even if two lives look alike from a distance, the texture up close is never the same, and that texture is the story. The universe helps with this. Stars are born and die, species come and go, and the future will hand us questions we haven't learned to ask yet. As long as there are minds to notice, new angles open. And even when the pattern seems familiar, the voice changes it, because the voice carries a time, and a body, and a history. There will be a last story only if there is a last mind. If the cosmos thins into darkness and thinking fades, the telling ends with the teller. Until then, the world keeps changing, and so does what it feels like to be alive. What will be the final change in existence? Maybe the last change isn't a crash at all, but a leveling out. Things change because there are differences, hot and cold, dense and thin, light and dark. So the universe runs on contrast, and contrast runs down. Stars burn their fuel and go out, galaxies drift apart, and even black holes leak away over unimaginable time. Bit by bit, energy spreads so evenly that there's nothing left to do any work. That picture has a name, but the idea is simple. When every difference has been spent, there's nothing left to mark time. Because time is just change counted by a clock, and a clock only ticks if something moves. In the far future, movement still exists as tiny jitters, but nothing builds from them and no new structure appears. So the last real event is the end of events. We don't know this with absolute certainty, but it fits what we see. And it tells us something human. Our lives have meaning because they're full of unevenness. We wake, we decide, we make new differences, and that gives time a shape. The final change in existence would be the loss of shape itself, when before and after drift into the same thing. And for us that makes now feel wonderfully bright. Could time start over in another universe? Start sounds simple, but time isn't one long tape that can only begin once. It has a direction because the cosmos began in a very tidy state. Then it's spread out and mixed, and that growing mess gives time its forward push. We call that growing mess entropy, and it's just a way to say the energy is less organized than before. So could there be another place where everything begins tidy again? Yes, in some ideas, new bubbles of space can form, and each one would have its own clocks, its own beginning, its own arrow. Or the old universe could squeeze and bounce, and after the bounce a fresh clock would start. Inside that new world, there wouldn't be a meaningful before, because the clock that measures before doesn't exist there. But it wouldn't be a rewind. It wouldn't play our lives again. It would be a new history with new chances and new limits, because the dice are rolled in a new way, and that touches something human. We feel time as memory and loss, and we dream of resets. The universe may allow many beginnings, but they're not do-overs. They're fresh arrows drawn from new order. So could time start over in another universe? It could start again, and it would mean a new story, not the same one. Will everything that ever happened happen again? It's tempting to picture time as a circle, a song that repeats. But the universe may not work like that. If there are only so many ways to arrange matter, then with enough time a state could return, like a deck that after endless shuffles falls back into the same order. That needs a sealed world with steady rules, though. Our universe doesn't look sealed. Space is stretching, energy spreads out, and disorder or entropy keeps climbing. So the arrow of time points one way. So the big picture doesn't loop back to the start. Some ideas sketch cosmic cycles, but what we see today is ongoing expansion, not a reset. And even in a cycle, an exact replay is wildly unlikely. Tiny quantum jitters send paths apart, so the same seeds don't grow the same tree. Could chance rebuild a copy of this moment somewhere, sometime? Maybe in principle, but the weight is beyond any useful number. And that copy wouldn't be linked to our past. It would be a new coin that just looks the same. What does that mean for being human? Meaning doesn't need a rerun. We live on a one-way thread held by memory and change. Patterns echo, and matter is reused, but this moment is its own first edition. So will everything happen again? Almost certainly no, and that's a reason to pay attention. Could time stop and start without anyone noticing? Imagine everything pauses for a beat. Every clock, every atom, every thought. Light holds in mid-flight, and hearts hang between two beats, and even the laws that push things forward wait. If all of that halted together, there'd be no change, so there'd be nothing to notice. When it all starts again, all the hands move on the same next tick, and the new breath is just the next breath. So from inside, a perfect stop leaves no trace at all. That's the key. Time isn't a thing that flows past us. It's the name we give to change and to the order of moments. If nothing changes, there's no way to mark a gap. You could ask if something outside the universe could time the pause. But if everything that makes a measure is inside, there isn't an outside clock we can use. What we do see is stretching. Move fast, or wait near a black hole, and your seconds pass more slowly than mine. You don't feel it, but when we compare clocks, they disagree. So time can change its rate, and we can catch it. A full stop is different. It would erase every marker. So could time stop without anyone noticing? Only in a way that's the same as it never stopped at all. Is time alive? We talk as if it is. We say time passes or runs out, like it's a thing with legs. But life is something that eats, grows, repairs itself, and makes more of itself. Time doesn't do any of that. It doesn't push events along. It doesn't choose. It's the way the universe keeps the order of change. A clock doesn't find time. It counts change. The earth turns, atoms tick, hearts beat, and we call those regular changes seconds and hours. And there's a twist. Clocks can disagree. Go fast or go higher up a mountain, and a clock will tick at a different rate. That tells us time is woven into the shape of the world, shaped by motion and gravity. It's not a creature in the room. It's part of the room itself. So why does it feel alive to us? Because change has a direction we can feel. Heat spreads, cups shatter, tidy rooms get messy unless we work on them. That push from order to mess is what gives time an arrow, and our minds ride that arrow. We remember the past, we imagine the next step, and the story moves. Time isn't alive, but life gives time a heartbeat, and that's why it matters. Does the end of time mean the end of meaning? Say the universe runs down, stars fade, clocks run out, and change slows to almost nothing. If that's the end of time, does meaning switch off with it? It sounds like it might, because meaning feels like something we make while things are happening. It needs a mind and a world and a moment to connect them. Meaning isn't a substance you can pour into a box. It's a relation. It's a signal that matters to someone because they can read it and care. So as long as there are beings who can think and feel, meaning is being made second by second. And if the seconds themselves stop, new meaning can't form because there's no next for it to appear in. But does that erase what was already real? No. The end of a song doesn't cancel the song. It fixes it. Every note has its place, and it keeps that place even after the last sound fades. The same with a life, or a culture, or a discovery that changed how we see the sky. Once it has happened, it is part of the universe's record. Some people picture time as a whole story, already laid out. If that's right, the last page doesn't delete the first. So the end of time would end the making of meaning, not the fact that meaning was lived. And that feels enough. Can nothing last forever? We say nothing like it's a box with no thing in it. But the moment we try to picture it, we've already put in space and time and darkness to look at. And that's not nothing. Even what we call empty space isn't empty because there's energy in it. Tiny pairs of particles flicker in and out, and the fabric of space trembles a little. So the best nothing we can make is busy. Then there's forever. To last, something has to sit inside time. But if there were truly nothing, there'd be no clock, no before and after, no change to count. So asking if nothing can last forever is like asking the silence of a switched-off radio to play a song. We can look at the far future. The universe may thin out into cold darkness, and stars will end, and black holes will slowly give off energy and fade. Wait long enough, and almost everything dissolves into a thin bath of light, stretched across a vast, still space. That still isn't nothing, and we know this feeling in our lives. We think a room is empty, and then we hear the hum of a light, and our own breath, and thoughts arriving. So can nothing last forever? It can't even start. Could the universe exist without time passing at all? Start with change. If nothing changed, would time be there? Our clocks tick because atoms jump and the planet turns, and our thoughts move because signals fire in the brain. So time for us is the record of change. But could there be a universe where nothing actually passes? There's an idea that the whole of reality could be a finished shape, a four-dimensional map with every event laid out. Nothing moves in the map because the map already contains the moving. It's like holding the entire film reel at once, not watching it run. Inside that map, a creature like us would feel a direction, because memories stack one way and not the other. Eggs crack and don't uncrack, because things tend to spread out and mix. That gives a sense of before and after. So the passage might live in the pattern of change inside the map, not in the universe as a whole. And there's a hint of this in some theories, where the main equation has no time in it at all, and time appears only when parts of the universe compare their changes. So could the universe exist without time passing? It could simply be. But beings like us exist as change. So we only ever meet that whole as moments and call their order time. Does time slow down as it gets older? It's tempting to imagine time getting tired and easing up like a clock winding down. But time doesn't age. It's the order of events, and the measure kept by clocks. Clocks can disagree. Move fast, and your clock ticks fewer times between the same events. Stand near something massive, and your seconds stretch compared with someone further away. But for each of us, locally, time always feels normal. A clock on a mountain runs a little faster than one at sea level, and we've built navigation satellites that correct for that every day. So time can run at different rates, but not because the universe is old. What about cosmic time? The universe has an age, around 13.8 billion years. Its expansion rate has changed, first slowing as gravity pulled, and later speeding up because of a kind of push we call dark energy. That changes distances, not the size of a second. A second now is a second then, if you're with a clock. So why does time seem to race as we grow older? Because brains are prediction machines. New moments demand attention and make dense memories, and dense memories feel long. Familiar days are compressed, and months slip past. The pace we feel is the pace of memory and change. Time doesn't slow as it gets older. We live at different speeds, and clocks keep us honest. Will we ever understand what time really is? Clocks don't agree, and that's the first hint. A watch on a fast plane or high on a mountain ticks at a different rate than one on a desk. So time isn't a single drumbeat for the universe. It's local, and it bends with motion and gravity. So what is it then? It's not a thing we can hold. It's the order of change, the way events are lined up so that cause can make effect. A clock is just a machine that counts a regular change, like the swing of a crystal or the vibration of light, and we use that counting to label moments. But there's also a sense of direction. We remember the past and not the future. Cups fall and shatter. They don't jump back together. That one-way street comes from disorder spreading, because there are many more messy arrangements than tidy ones. The early universe was unusually tidy, and that gave our arrow its push. Will we ever understand it fully? We can already explain why clocks disagree, and our navigation satellites prove it every day. The missing piece is how time fits at the deepest level, where gravity and quantum rules meet. It may turn out time isn't basic, but rises from relationships between events. If we reach that, we'll know more than what time does. We'll know why there's a now at all. Could time be an illusion we all share? It starts with a strange fact. We feel a moving now, and we nod at the same seconds on a clock. But the universe doesn't carry a single master tick. Signals take time to travel, so two people far apart can slice the same events into different views of now, and both be right. So the flow we feel can't be a thing out there sliding forward. It's built from inside. The brain keeps a small stack of what just happened and a sketch of what's about to happen, and it stitches them into one smooth line. That makes change feel like motion through time. But is the whole of time an illusion? No, because change leaves scars. Hot tea cools, a glass shatters, stars burn their fuel and fade. Those processes run one way because disorder tends to spread, and that gives an arrow that minds alone can't fake. And clocks are matter too, so they bend to speed and gravity. One runs faster on a mountain than at sea level, which means time is woven into the world, not just in our heads. So the passage is our shared story, tuned by memory and expectation. The structure it rides on is real. We move through change, and we give that motion a name. What happens to time when no one is left to count it? We count time with clocks and calendars, but that's just us keeping score. So what happens to time when no one is left to count it? It doesn't vanish because time isn't a number, it's the order of change. A clock is a thing that changes in a steady way, and the number is our label. Take us away, and the changes keep going. Planets still swing around stars, rocks still cool, light still crosses the dark at the same speed. The universe doesn't wait for us to nod. But there's a twist. Time shows itself through difference, through before and after. If nothing changes, there's no then to point at. Imagine the far future, when energy is spread thin and no engine can run. No stars to burn, no chemistry to climb, no clock that can tick. There's still a stage, but no cues, no beats to mark. So without counters, time is still there as the link between events. It's the spacing between moments, set by the way the world evolves. And if events fade and differences drain away, the word time loses grip, not because it's gone, but because there's nothing left to measure. In that sense, we don't hold time. We witness it while the universe has things to do.